Hello. Been busy the last few days, but today I'll be knocking out Everybody Code's Quest 12. Got my VS Code ready, got my 12 folder ready, got my test ready. Here goes nothing. Quest 12. Boom. Desert shower. Okay. Well, looks like some kind of graph. Projectile path, shooting power. Oh, this is math. Okay, so here my number is 13. Okay, so let's see. Launch from A, launch from B, launch from C. Okay, targets, destroy all targets. Start from the top blocks of the target structure to prevent any unpredictable fall. Ranking value, segment number multiplied by shooting power. B times 5 equals 10. For the example shot above, ranking value is good to blah 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 blah. Okay, so B is 2. Okay, so it's character code 1 indexed times shooting power. Okay, I got it. It's your ranking value. Sum of all rankings of all fired. Okay, so you're supposed to shoot the top ones and then the lower ones. Okay, what's the math? Constant speed. Oh, great. We can ignore friction. I love ignoring friction. Projectile 45-degree mini segments as the power. Same number horizontally before diagonally downward. Okay, I know there's a math way of doing this, but I don't know the math way of doing this. So we need positions of launchers and positions of targets. So let's do that. World equals notes split on the new line. Map each line to an array for mutability. Const launchers, const targets. We just need to find all this. So for r equals 0, r less than. Yes, it is. I was about to go x, y, but I've been using our rows and columns this entire time. Okay, we have our thing. So we're looking for alphanumeric character that's not T. Okay, so basically if const char equals world RC, if char greater than equal A and char less than equal Z, that means you're a character. If char is a T, targets.push RC, else launchers.push RC. So we have all of our things, and they say destroy all targets, something about top blocks to unpredictable. Okay, so I start from top and I start from left. Okay, so const all targets sort A B. So I want negative r's. Const r diff equals a dot r minus b dot r. A to B means from smallest to largest. That is what I want. If r diff, return r diff. Otherwise, it is C0 to C big number. So it is 0 to largest. So it is ascending. So exact same thing. Return A.C minus A.C. So these are the targets I'm to destroy in that order. let's fix this. R number, say number array. Let's just save ourselves some typing there. There we go. So we have our targets ordered. We also need our launchers ordered, which is same thing, but just with the one. Return. Sharon, I told you. And this is launchers. Okay, so we'll go through launchers and we'll go through them in the same order, basically. So for let L equals 0, L less, come on, L less than launchers dot length, L plus plus, const origin equals launchers, const dest equals targets, targets L, and launchers L. Okay. I have to do the thing that makes it go to the place. So can I just try every shooting power? I can just try every shooting power. So what is this? Dest R C R C. I guess that's not how TypeScript works. Apparently, what did I do? R number C number. So I think we have to do math. Well, what power are you doing? I need power. I'm doing this a whole lot. Let's say make my life a little easier here. Boop, boop, boop. Okay, we have all this great stuff going on. So what was the rules? As many segments as the set power allows. Okay, so 1, 2, 3. So you immediately go up that many, cross that many, and then downward until it there's totally math behind this, but I don't have it in my head at the moment. Const R1 and C1. So R1 equals R plus power, const C1 equals C plus power. And let me make sure these go in the right direction. So I need negative rows, so I'm going upward, and the column needs to be positive because we're going rightward. Const R2 equals R1, const C2 equals C1 plus power, because we're going just rightward. And now it's continually down until we are at a position of the ground. So I need ground R. Ground R number. So let's figure out ground R. Well, ground R is basically length of the world minus 1. Yeah. Let's make that a variable. R equals world.length minus 1. Okay, so we have that information. Now we need to subtract the difference between the row and the column to get the number to move. And then we need to calculate how high we are, basically, which is the difference between current row and row ground. I mean, let's look at it. Row ground is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. And I am at 0, 1. So I need to go 1, 2, 3, 4, 5, 6. 8 minus 1. Or 8 minus 2. Whatever. Math. So I need to subtract the ground. Ground subtract current. Const height equals ground R minus current, which is R2, which means const R3 equals R2 plus height. You go down, and const C3 equals, you're going to keep going down, but you're also going to the right. So that's C2 plus height. Now we're on the ground. Are we in the ground? We might be in the ground. It's kind of an off by 1, but we'll see about that. I think I can do some lazy visualization of this to see what's going on. Okay, so we have the origin, we have the destination. We're gonna start trying everything. More efficient will be kind of binary search to find when I hit the target. Oh no, I need to hit targets. Whoops, I'm hitting the ground. It's basically calculating if my current position plus 1 plus 2 plus 3, so I can loop that. I can also math that, which is going to be the easiest. Let's loop that. Let's loop that, yeah. So while R2 not equal, so let's make let R3 equals R2, C3 equals C2. So basically, until we hit the ground or something important. So R3, there we go. Not equal ground R. Here's the thing, I don't want it to hit the ground. Well, it's the thing you're pointing at isn't a thing. So I have the location. I have the ground. I have the. You know what? Well, I have the world now. And congratulations. We would just calculate ground R right here. R, and you know what? We don't need ground R. We're just looking at things. So while world R3 C3, let's do some conditional. No, we won't go off the world. Basically, it's not empty air. That's what we're looking for. So we will do some conditional bits there. R3 plus plus C3 plus plus. Just keep going, buddy. And then we'll return. I'm gonna keep these around. I might need them. We're just gonna return these, right? So calculate the destination. You shoot from here in this world with this power. And this is going to be determining if we're actually hitting the stuff. So, and if our destination is in space, then we're worried. Do we care? We don't care. I think if everything works right, it'll terminate before we go into space. Let power. Now we can do some minimum power calculations of 1, 2, 3, 4. I was about to do some cool optimization. Let's start at 1. True. Very dangerous loop. Don't do what I do. So if, well, cost hit equals calculate destination from the origin in the world with a power of power. If hit R equals dest R and hit C equals dest C, which is really should be target, then congratulations, you hit. You can break and we'll give you an answer. So let powers is right here, and it'll be powers push power plural, and then we return. Actually, return the thing too. Let's call it hits then. Instead of just power, we also have the number of the cannon, the launcher, whatever thing we're doing here. What are we? It's the thing, right? Segment number. So I guess this is a world. World RC. It's what you're launching from, which it's just launchers. So origin R, origin C, there we go, and then we return hits reduce A B, A plus B, start at 0. Now B, I did character coding stuff my last one for this. Let me go steal. Where is it? Was it here? I don't remember where it was. There we go. Character code math. Ba-da. Okay, so it is thing multiplied by thing, right? So segment times power. Put these all in parentheses. Boop. instead of the world character code at it is a dot. And I don't have any autocomplete here because I haven't set it up. So it's a segment minus that plus 1 times a dot power. Okay, I think we're good there. We're not using B because we are a goof. This is all supposed to be B. A is our accumulator. Again, power of types. Ain't got none. Okay, so I'm a little worried this is going to explode in my face. Let's put some breakpoints on this. Yeah, let's get in there. Okay, right, so let's see what we hit. The other one also might well look in my face. We hit 0, 3. So row 0, 1, 2, 3. You hit the sky? How'd you hit the sky, buddy? Is my input a very small universe? It is, right. I don't have a sky, so I hit the roof. So if R is under... so we kind of gotta not worry about this. So while the thing you're poking at isn't... So yeah, we just gotta do this differently. So as long as you don't hit a T, and also confused how this while loop is working because I think I goofed it up. So while it's not a T and both of these are true, so you're flying, keep flying, you're gonna keep going. Okay, so I'm gonna go into the calculator for that one because I have doubts that it does its job. Let's get in there. Okay, yep, calculating the destination. I assume this is all correct. Power of what? Power of 1. Row 1, C1, which in my world is that one. So in theory, should go up 1, across 1, up 1, across 1. Okay, this visualization really would help. See if you're shooting power of 3, right? Let's just zoom on. Row 4, column 7. Boop, 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 boop. Yeah, that feels about right. I don't know. You didn't hit. Very sad. So what does C need the power of? Power of 2. Did I just go past 2? Ooh, I did. Row 2, column 8. Did I hit the thing? I hit the thing! Oh, okay, so it's working. What does B need a power of? Shooting power of 2. Boom, you hit it. A needs a power of 3, though. I did math. Is this thing working? That's a number. It's a passing test. So, real input. Oh, I haven't looked at the real input. A lot more targets. Oh, do I just keep shooting? I'm confused if I should be... So we have multiple elevations. Okay, these two are shooting other elevations, so I just keep cycling through them? Like, what's... Do I have to do some kind of guessing or thinking to figure out which combination of shots is what I want? This ain't gonna work. Yeah, why did I push the button? Yeah, let's not do that. Oh, computer don't like it. Nope, okay. Die in the background, VS Code. Guess I gotta reread the problem. Catapult is 3 segments. Possible to fire up to 3 and simultaneously. Yeah, go for it, buddy. Reopen. Okay. Each catapult 3 segments from bottom to top. They are labeled A, B, C. Each can launch independently. Oh, so it's how many firing cycles. Interesting. several targets. With each projectile only destroying the first it hits. Start from the top blocks of the target structure to prevent any unpredictable fall. So I have to start from the top ones, and looking at my input, I have this. So do I destroy this tower first? These three, and then these three, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I destroy all the tops layer by layer. I'm not sure. I guess I can try both. Alright, I believe my sorting currently has me destroying all the tops, so let's go for that. Although, if my B does... But these all take a bit of power, don't they? Yeah, I'm trying to think of a scenario where, yeah, anyone can destroy any other target. It's all good. Yeah, so... We're not going for launchers, we're going for targets. And we're just modulating you over .length, because we need to destroy all our targets. So previously I ran this, it died. Let's try to avoid that this time and put a breakpoint here, debug into there, and see how many we swash. Okay, so I mean we're going. Nope, get me in there, let me in. Right, so we're in the sky. What kind of power are we using? Undefined. Hey, what happened here? What in tarnation? Well, you're gonna stop that. Okay, part 1, doing your job. Part 2, who told you to go with undefined power? Or not part, example. Okay, let's get in there. Yeah, look at that. Completely defined power. And you're going to go power 1. You're going to really try. You're not going to make it anywhere because that is way too small. You're going to fail. You're going to the next power. Okay, sure. So we'll just keep hitting this until I see the badness. Is that my life now? Okay, so it needs to be on the next previous one. Okay, all the jumping is going to eat me alive. Let's just keep in here. Eventually we gotta hit something. We hit something, and then we went to infinite power land. Power is 11. You never hit the equal sign. Oh no. Okay, well, it's not a T, and the R3 is not ground R. Not equals length minus 1. I'm acting like this is space, and I just fired it off the space platform into wherever space takes me. That's what went wrong. Nope, still a problem. Add it and do it. R3 is not equal world length minus 1, not equal 6. We got there at some point. We're in the negatives. What power do we got? We won't be able to see on the power because everything's gone. But we're coming back down to Earth. That should be illegal. Okay, you're gonna come back down eventually. There we go. Hey, that's a lot of power. Why? You've never hit a target. Well, you've never hit a target from your origin. Okay, so basically I can stop looking at power when I hit something past it. Yeah. So if my hit is this, if hit, nope, hit C greater than dest C break, you couldn't hit your target. So we're breaking, but we don't want to skip this target. So let launcher I equals 0, and then it's launcher. I can't type anything. Launcher I. There we go. Keep doing your modulo thing. And once you finally hit something. No, it's not launcher. It's target that needs to move. Dang it. Or it's target that I need to keep trying different things on. Hold on. I can't hit you from this one due to impossible odds. I need to try to hit you from another one. Same target, different launcher. Okay, I was right. I control it away though. And then once you do hit something, good job. You can move on to the next launcher. But when you don't hit something, so we always just moving. If we're always moving on both, then what? I have confused myself. The problem is I need to keep trying a target until it's hit. Do I need? I'm trying to think. So I'm going through all the targets. I just need to try all the launchers. Then you start. I start on one. Or do I need to? Right? Can I just shoot everything from the first one? Will it not matter? Or let L equals 0, L less than launchers length L plus plus. Just go for all of them. Right? What's it gonna matter? Feels like it doesn't matter. Why do not tab? Drop launcher I, drop that. Okay, let's see if that happens. Let's add some curlies here, because I know we're gonna break. And some breakpoints here. First, let's make sure this didn't break. Okay, it does not matter the order, at least for that one. Okay, so eventually we're gonna hit here. These are our options. Let's zoom. Let's stop looking at that. Boom! You overshot it. Very sorry. 419. You overshot it. 418. You hit it. Okay, this is looking good. It's a number. 202. 202. And again, enter doesn't submit these forms. No. No. So the trick, so there are two things. Am I either firing from the wrong launcher, which I could be, or I'm firing at the wrong targets. Because I'm doing them in the order of this row, this row, this row. It's the launcher target combos that have to be wrong. Because firing at it from this one would give me less points than firing at it from this one. So do I prefer minimum or most? I mean, I can just see it. So 202 isn't it? If I invert my launcher's order, that'll tell me if there's any impact to this. There is not. Ooh, that's unfortunate. So it's my target order. So I want to sort basically const cdiff first. If cdiff return cdiff, otherwise return rdiff and defaults 0. Still 202, huh? Interesting. 6 plus 4 plus 3. Yeah, my hits are going in there. Yeah, if I fail, I hit. Okay, so let's do the paranoid thing. Put a breakpoint here. Make sure we get the same count in as we did out. So yeah, how many hits do we got? 13. We had 15 targets. You missed 2. How did you? Oh, there's nothing saying you have to add a hit. Okay, that's a problem. That means all three targets tried to shoot you, and they missed. Interesting. Oh yeah, I don't have the tracking information of which targets were actually hit, so I just need to track the ones that weren't hit. If hits length not equal targets something something other. Let me see. So you're going through launchers. You don't make any. If hits T, if not hits T. We are sad. And I'm putting a breakpoint here because you failed. Okay, make sure one still works. Oh, we have 3 sadnesses. Oh, that's if none of them hit. I mean, well, that was meant to be if none of them hit. It ran when some of them didn't hit. Okay, yep, so there are 2 problems. Let's get in there. We were not able to hit row 1, column 14. Our destination targets T. Row 1, column 14. What are you talking about? 0, 1. Okay, 14. Here we go. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14. You weren't able to hit this fella. Okay, who's the other one you weren't able to hit? 21. So 14, 15, 16, 17, 18, 19, 20, 21. But you're able to hit all the others. My thing increments 1 by 1. Which means it would have to be going here, here, here to miss you. Or here, here, here to hit the one below you. Interesting. Now what power are we... Oh, power's not in this loop. Top to bottom, which made 2 hits. So I'm guessing... Who have we hit? I mean, we're not seeing who we hit. Let's look at all destinations. So stop here. Breakpoint there. Let's get back in there. Okay, destination 114. Okay, you literally first one. We cannot hit you. That is sad. 121, we can't hit you. 127, we hit you. We hit 29. We hit 31. So we hit all the next ones, and then we go below, which we cannot do that because we didn't actually hit the ones above you. So we need to figure out why this no work. Thankfully it's at the front, so that's something good. Yeah, let's see where we are hitting. Let me back in. Okay, hit row 4, column 7. What's my power? 4. So, you know what? Let's just do this. Function draw hit world string lock cost previous equals world lock R lock C, and then what is it? World lock R lock C equals X. I want to have this on a timeout or something. Really, I want this async. Promise. Actually, I don't need that. I can just do it as here because I'm debugging. Console log. World join. Well, map L dot join Then world join. So let's console log lock. And then, yeah, this will be where my breakpoint would live. Great, let's do this. Let's not make it asynchronous. Just gonna make my life harder. And let's do a straw hit. No, sure. World lock. World hit, sorry. There we go. Should be good enough. Let's get in here. Yeah, I mean, I do want to see what's going on, but where's my output? Oh, do I not get this because of... annoying. Yeah, hit the ground. Next. So I do actually want a breakpoint down there. Next. Yep, now the next one, you're going to hit something in the column. And this is an illegal hit, so where are you going to go? It wasn't. It wasn't. Okay, you're going to go one more power. It's going to, throw you over, isn't it? Yeah, this is exactly as I anticipated. Like, we are going literally one over, one below. What are you supposed to do in this situation? Okay, well, I assume my destination or my origin. Okay, go. Oh, other things are getting hit. So I'm on the next cannon, I believe. So you hit too low. Okay, so I'm assuming the third one will be able to hit high enough, or I want this one hit. I thought the previous one was this close, but sure. Okay, I'm guessing the next one will be hitting. Yep. Okay, you're obviously the lowest one on the pole. Make sure you hit the ground below it. Don't think that's legal. Boom, you hit it. You hit it. You did good. $114 got hit. How do I... Oh, I hit it. And then do I keep trying to hit it? I'm really confused about these breakpoints. Slot 14 was my problem. Stop looking at it. I've confused myself again. 329 is my problem. Okay. 0, 1, 2, 3, 29. I mean, this is 14, 15, 16, 17, 18, 19, 20, 21. 22, 23, 24, 25, 26, 27, 28. So it's you over here. So yeah, for 329, we never hit nothing. And for 331, okay, so your two friends at the back there, we don't hit you. Very sad. Let's actually debug them. Crazy idea. Put that breakpoint there. Debug back on it. Come on, where are we? Yep, 114. I need to get to the 3s, then the 29s. We found ya. Okay, let's draw these out again, I guess. This is it. Let's see what we're looking at. Yep. You got a few to go there. Can I put a watch on this instead? This is getting annoying. Okay, that's kind of more annoying. If only that log would be showing me somewhere, but no. Do I have a test output? I don't. Keep running it. So we got a few more to go. these targets don't exist, and it's hitting the targets that are been knocked out. Oh, that's the problem. So when they get knocked out, I have to remove them from the board. Okay. So once the target's been hit, which is here, and I say world dest r dest c. What's my hit algorithm? It's not a T. Equals O. Sure. Will that hit now? I think we got it. Boom. Okay. Targets are now ruins of a tower, which served as an observation post. Some of the ruins require 2 hits. Okay, that doesn't seem too much of a challenge. Hey, give me the rest of my life. Hey, no. Okay, how many do I need to explode all this? 22. We got this. Now, they basically just have health now. So when we put this number in here, solve quest 2. You know what? No, I can just modify existing. Yeah, I'm just going to modify existing. Give me my notes for this one. Ooh, wow. Wow. Still hope the top-down approach works, because, yikes. Okay, so, targets. Yeah, I'm going to add a target's health or something. Hey, where are my targets? Where do I define those? Targets.push H1. No, let's call it 2. And then they decrement, and then they decrement. And once you're 0, you're dead. And H number. Congratulations, you're a weird thing. Don't worry about it. Okay, so we're good there. We have health. Well, only if you're a cool thing. So elf equals car equals H, which I literally have conditional for here. So let's just boom, you're an H. Then your health is 2. If you're not, your health is 1. You're very boring. Okay, let's implement this health system. I think if you hit it, we should just double your hits. So I think I just implemented a health system to ignore the health system. So if dest.h equals 2 hits, whoa, push another one. Yeah, just duplicate that. Much appreciated. So yeah, the health system is useful for tracking which is which. So there's some use there. Yep, we still have our sadness if sad things happen. I would go for it. Make sure I didn't break nothing. I broke it. 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 If it's T, if it's H, if it's otherwise. Jeez, how did I break this? What have I done? I touched a few lines. I have this extra pushing, and I have this H. That's all I did. What did I do? No matter what I did, it's... Even though this is the previous one, I broke it tremendously. Yeah, targets have a new thing. I'm very, very careful with my changes right now. It was working before. I paste a new thing and it dies? Okay, I need to be very careful going forward. Whew. Partial diff, clipboard. Okay, what did I break so drastically? Yeah, I put in the right number. Now this isn't part 2, but I'm confused as all heck. I let my confusion stumble me enough. We're just gonna move on and get really confused about it later. So I have T, I have H. H is 2, double hit. Have an example right here. 22, that was actually 4. Okay. You didn't double hit. I don't think you double hit. Hey, buddy. Why didn't you do the thing? Boom, so you made a hit. What's your destination? You're a normal tower. Cool. You did your job. What? You just hit one thing? Am I only collecting towers? Do I have other T? Ah, there we go. I only hit T's. Doesn't explain why this one's broken. Gonna keep ignoring that. Boom, okay. Time to crash my computer. Bye-bye. So either you're doing a lot of math or you're gone. Either way, I should have put you in a debug session. We can do that now. We'll start the destination layer and the hit level. And let's actually get rid of that log. That's going to kill us. Okay, let's see where we hit wrong. Destination, hit. Let's just go for destinations. How many targets are there? There's only 297 and we're at 6. So I think it's going to be tough to figure out which one is the problem child. Oh, no, he just wants to work now. Sure. Whoops. Okay. Some of the blocks need 2 projectiles to destroy. So, that's all that changed. 2 times 6 plus 4 plus 2 times 3. Yeah, 2 times, because you just do it more. That's perfectly fine. I duplicate my hit in there. And it works on the example. Yay. Fun. The order of this still is top to bottom, I believe. And as we get rid of them, we poof them away. They still remain in targets, but they're before us in the array, so that's fine. Power, segment. Yeah, we do double the math, that's fine. Interesting. Means something else is wrong. Do I investigate what broke my previous example? Stop that. I think it might be worthwhile because it didn't break on its own. How do we go so large now? Yeah, it's supposed to be 230. Let me go grab my notes. Try to bork up the text. Still angry. 1670. How many hits did you make? How could you be allowed to make that many hits? 48 hits on 15 targets. Excuse you. So here's the thing. Once you hit the fella, you give up. So basically, once a hit's been made, that is good. Let's just go ahead and save thing. Well, that target hit. It's false. Boom, you hit it. Hit equals true. Good job. And then this loop here, if target hit, break, stop launching things. And yeah, I guess that part will always be target hit. See if that works. Still so many hits. How have we done this? Is this looking better? This is looking better. Be smaller number. Don't think it's gonna work, but you can never be too safe. Are the ones still good? Okay, our examples are still good. Let's get in here. Yeah, 15 hits on 15 targets. Uh-oh. You don't have 18 launchers. Where the heck did you get 18 launchers? Who gave you 18? Oh, I had this condition. That's what broke it. Didn't realize why I couldn't solve it with refactoring, but that's what broke it. I was firing projectiles from every position in space. Makes sense why the power got so low. I was firing at it from, like, beside it. I was firing at it from every T, because the T's were being considered launchers. Big number go. No. Oh, your answer length is correct. The first character of your answer. I didn't realize it ever told me that. Those are some nice hints. So it is 2 something something something. Something. Yeah, so it starts with a 2 and it's those bits. Well, that's nice of it. Please don't work for everything. Dang it. That's not fun to debug. Okay. Yikes. I mean, we can do some basic stuff. Let's debug in there, make sure the counts are correct. I'm going to have more hits, actually, so the counts won't be exact. 297, 332. How many H's are there is basically the question. 1, 2, 3, 4, 9, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 34, 35, 36, 37, 38, 39, 40, 41, 42. 42. Which means I would have 42 plus whatever I have right now, which that don't look right. That don't look right at all. So targets length. Let me also just shove 42 for my eyes. Minus hits length. Length 35. So I hit 35 H's double. The heck happened? There's a lot more H's here. Okay, I'm just gonna do some manual stuff. How many freaking H's are there? Targets equals targets. Define T dot H triple equals 2. Yeah, let's get back in there. Double targets. That's not a filter, you goof. Try it again. Right, restart doesn't work on debugging of test. That's right. 42 double targets, so it should be 297. 297 plus 42 plus 42. Yeah, you didn't hit 381. You didn't do 301 hits, buddy. Which means there's a possibility you didn't hit at all. Ah, yikes. When I double hit, I say I hit, and then I do all the things. So I guess I'll do logic here. If target hit, yay. Else, boo. Yep, and I'll find something here. For some reason, I wasn't able to hit one of my targets. Boom, there's the failure. 3 and 78. Okay, so it's 0, 1, 2, 3, and then 78. You weren't able to hit this one? Why not? You had all 3 of those launchers. You do have 3 launchers, right? Yeah, you had 3 launchers. You weren't able to hit this little one. I see no reason. I mean, you destroyed all the ones above it. Then you went to hit this one. You were like, nah. Or is this the first one you tried to hit? Then you have 22 other hits. 4, 4, 4, 4. 16, 17, 18, 19, 20, 21, 22. Yeah, you hit all the ones above it. So you did go top down. You can hit this one. No reason. So 378 copy value. If my destination, I mean, what level of power would we even need to start hitting this? That's a good question. Let's get the bug point, conditional breakpoint. There we go. You're supposed to hit the one, and you didn't. Why didn't you hit it? Boom, we got it. Let's stop it. Let's follow Mr. Problematic. Boom. Okay, we found Mr. Problematic. Let's just go straight to the attempts and the failures. Hopefully I really get access to this function. I'll be really sad if I don't. Dang it, JavaScript. Why you gotta do that? Ouch, I need to put it back. I need to go inside. I don't want to go inside all the time, so I guess I'll get rid of that. Let me in. I need these. I got rid of the good one. Oh, gotta start putting stuff back. Get rid of the bad. Get rid of the bad. We found it, which means now we can put the breakpoint on here. Go inside. Put the breakpoint on here. And look at the world. It'll be very disappointing for like the first 10 powers, I bet. Yeah, I don't need to see you anymore. I mean, I like to look if you hit stuff. Or if you go over stuff. Three more. Yeah, I think I need 1, 2, 3. I mean, I know it is growing. 1, 2, 3, 4, 5. 6, 7, 8, 9. Also, I am going for a tall one. So at some point... Oh, I'm hitting a lower thing, right? I'm giving up because the hit on the row is too low. I need to allow it to keep trying to aim higher. Boy, so close. Okay, right? So my hit is going to be 1 off. Oh, well... I guess I went past the column. So yeah, if you're over... So yeah, this logic for determining you missed doesn't work. I know this is here for a really good reason. For me, basically, like, not keep trying. It's tough. Yeah, so I hit here, so it was like do. I need to know if I've basically gone over it. Yeah, I'll have to do different calculations. It's kind of like a trail thing. Highest R, highest C. That would give me like this straight line up here if I give it highest R. I can use that to determine with a little bit of math if I went over. So if I subtract the highest R from my position, it'll basically give me the R at my position, and it'll tell me, well, if it was lower, then I missed, but if it was, I could keep trying. But if it was higher, I missed, and I shouldn't keep trying. So I need the highest R. Hit or lowest R. Peak. There we go. We'll call it peak. Sorry, good. Got escape from me. Hit is this, and then peak, which I'll calculate. Well, I don't know. I need to calculate it. It's R1, right? Or it's R2. Both are equivalent. R2 is the one I'm going for, though. Yeah. So it's hit, look, peak, number. Okay, now we can do math. So here we go. So const C at peak. Okay, let me look at an easier example. Let's say I'm watching over. That's not an easier example. Give me an easier example. Okay, yeah, I do the launch, blah, 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 blah. My peak is 0, 1. Yeah, let's just say my peak is... Interesting. I need the column of my peak. So I need the entire coordinate, not just the actual peak itself. So peak is R, R2, C, C2. It's before I start going down. So now I'll need both of that to calculate you know what? R at thing. And I don't use the target fully, but it's good enough. Let's see at target. Let walk above target equals R0, 0, C, 0. Okay, so once we make it above the target, which we assume is in the descent. So yeah, if it's 0, that means we never made it. Or if the thing is the thing, that means we did make it, but one of these could be it. I don't think I need all this information filled in. If C3 equals target dot C, lock, no, above target equals R, R3, C, C3. That's what we want. And then peak is lock above target. Sure, doesn't really matter. I said as I made it matter. So if it's 0 and 0, then we don't care about it. Actually, let's null it out. And lock or null. I'm trying to think of this calculation. Let's go back to the visualization. Let's imagine we are going straight and we are here. That's bad. So a lock above target of null would also conclude this. I need the thing to be accurate, darn it. Okay, so we're just gonna do this and be like, hey, if you went over, dang it, math. So much math in here. Which part of it is my fault overcomplicating it. Let's just do for loop, right? For p, let p equals 0, p less than power p plus plus, and let's just keep this way up here. We'll do this for all of our changes. Let r1 equals r. Wow, what happened there? Let C1 equals C, not C3, just C1, 1, 1, R1 minus minus, C1 plus plus. But where did my fingers go? R1 minus minus, C1 plus plus. There we go, the hard way of doing this. And then another for loop for the C's. It's just C going forward. So doop, 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 C2. No, not like that. C2. Let's move it up. R2, C2. Make it a let. Okay, now we have stupid thing being tracked everywhere. It's fine. Copy this line. Get rid of the good way. Go back to the bad way. Okay, we have it. 1, 2, 3. Got the thing being tracked. We have the location above the target. Well, location... If it's not above, then it's not above the target. Dang it. And R1 greater than target R. There we go. Jeez, I've complicated this. We'll do this for R2 and for R3. There we go. I've sufficiently complicated this. Big fan. Now, let's look at the thing. If we have a location above a target, that means we know we give up, which means we should be able to just completely ignore this. Lock above target. Yeah, so if lock above target, you missed. Oh, I also need the target, that's right. Or the dest. What's the worst that could happen? Yeah, that was it. That was the worst that could happen. Let's get back in there. Right, we're also doing visualization still. I just want to see how you never do the thing. So I want this one. Though I'm never going to turn down a good look at the world. No, look at the world. Okay, you hit it. Good job, buddy. Good job, buddy. Yep, you hit it. You're breaking. You're doing good. Basically want the non-hits. Oh, not logging the thing I want. Yep, you're going for the next target. Aiming for O's. You missed, by the way. You went through a previously knocked out target. This one depends on our destination. What is our destination? 8, 3, which is 3, 8, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. So we should have location above the target. We don't. We don't. You had one job. You went over the target. You did not track its location. At least I know what I'm looking for. Destination 3, 8. Let's put a real breakpoint here. Let's stop this. Restart. Destination 3, 8. I want the real breakpoint here. Doesn't really matter. Yeah, skip some of these. Let's skip a lot of these actually. Let's get Honor for Our Life. Yeah, so where's the destination? Oh, well, I lucked out. Okay, so we're going for this one. We're going in. Yep, you are above the thing. Okay, I have to think through this one now, because looking at the right column, and your height is above its height. R1, R2, R3. It's not greater than, it's less than, darn it. That might be it. If it's not, we'll get to restart VS Code again. Woo, okay. Loving it. Oh, why did I even try it? I was really hoping it's like maybe the example is wrong, but the real one is correct. Like that's ever happened before. So I'm getting zeros now. That's interesting. Which means I probably got a lot of sad faces. Where are all my sad faces?
That happens when I don't hit. Okay, well, not sad faces, but where are my failures? Yeah, my target hit. I have all that. Let's get back in there, I guess. Something went wrong. We have no hits. We have no targets. Oh, did I break the... It was me. I was the fool. Ah, that's concerning. Because this one took a really long time. I believe it will work. I just have to give it faith and time. I really should have put a breakpoint in there. But while that goes and eats my computer alive, we're gonna see if this. Ooh, I think this is it. Correct length, correct number. Let's go for it. Boom! There we go. Part 3. It's a meteor shower. Oh, great. Catapult. Blah, 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 blah. What in tarnation? Are these moving targets now? 6-5 moves as following. Okay, at least they're coming in at a consistent rate. If the launch from segment C with a shooting power of 1 at time 0, he'll have the target at time 3. Oh. Okay. Collision at a non-discrete time. Wait for the meteor to move horizontally and vertically. So you can only hit them when they're on a position. Okay, so we have some branching possibilities here. So time and moving targets. So I'm trying to think. At any one time, I can only fire all 3 launches, right? Do it's a meteor shower, constant speed, 45 in the direction, 1 meteor, fire multiple simultaneously. Note all meteor relative to A, space rock. Okay. And what are these? Oh, these are meteor positions. Cool. Cool. High in the air as possible. No waste. Lower ranking is chosen. Okay, so I prioritize based on as soon as possible, not like let's wait until we can shoot it with the least thing. Okay, shoot down the meteors as high as possible, but at the same time, more than one way. Gotcha. Okay, that makes prioritization a little easier. So we get all the rocks, and we're like, okay, we're gonna try and shoot it with the A first, and we're like, we can't hit you, buddy. Then we'll try with the B, then we'll try with the C, and finally we'll be able to hit you based on one of those 3. If we can't, we advance time. Mathematically speaking, yeah, there's probably another way of doing this. Simulation going though. How do I know if I've passed it? Basically, if my column passes it, or yeah, if my column passes it, then I know I've missed ya. Is there a situation in which my column would pass and I haven't? Nope, it's impossible. So if my column passes, I miss you. So I aim, I shoot, and time advances for both. So I'll need to take in the meteor and the time, because the meteor's position will constantly be changing. And if at any time my C is greater than its C, well, yeah, I've missed it at this time and this power. But I can boost it to the point, so that'll allow me for the initial. How do I know, like, okay, I've tried enough power? Let's try on this. Okay, that's a horrible example. Let's try with C. What's the actual answer here? Okay, so with a target power of 1, that's great. Okay, target power of this one's better. Okay, how do I know if I've aimed too much power? Let's say I just kept going. I have sent it with too much power. Not if the row's too high, because we can come back down. If I have a target above projectile, or a location above thing. Okay. Whew, this is a toughie. Let's get started. Put the real number in here, I guess, first. Celebrate that. And here we go. Yeah, part 3, you're gonna need a new one for that. How many actual meteors are there? Yikes. Look at all them big... Oh, man, that's gonna destroy me. Hey, look at 1010. That's cute. Gonna destroy a computer. Okay, let's make that function. Solve quest 3. Note string. And targets equals notes dot split on the new line. Dot map along L dot split on the space. Map each to a number. Congratulations, there are a bunch of tuples. Great, I have targets which are all, it's an array of tuples. Okay, so we have that. I guess our launcher positions doesn't really work because my things have always been row based. So I have to change my coordinate system too, which changes all my calculations. Yikes. What is their coordinate situations? So, what is this? 0, 0? 0, 1, 2, 3. Go away, get. 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. No, that's wrong. It's a 1 base system. So 1, 2, 3. Because this is on 7. Right, okay, so 1, 2. Oh, wait. This is X off the ground, I bet. 1, 2, 3, 4, 5, 6. Oh, all my coordinate systems are different for this. Right, so it's basically a rewrite using their coordinate system. Thinking about transforming theirs into mine would work, but probably not, and it might just be better to go with their system. Because this brute force simulation probably won't survive. And I need to use whatever the real math they're wanting out of us is. And with that, I am going to be taking a break. I have returned. We are going to finish the part 3 of quest 12 of Everybody Codes. My last was basically, it kind of changed the game a little bit to saying, okay, now you're given a list of meteor positions. They are making a downward trajectory, and your launchers need to intercept them at the best time with the lowest launcher possible. So, that's the challenge, and my code is not prepared for that because it is parsing things every other way in the universe. Using rows and columns from top left, not with that the new coordinate system and all that stuff. So it's basically a new function, a new rewrite. So we have our targets. I think we need to
redefine where our launchers are at. So let me look at the image again, see how they do coordinate placement. So 6, 5, 6, 7, 10, 5. 2's on 5, 1's on 7. Okay, I think this is 6, 7 right here. So I would just grab this and just shove it down here. So 6, 7. You are 6, 7 because 0, 1, 2, 3, 4, 5, 6, 7. And 0, 1, 2, 3, 4, 5, 6, 7, 8. Count from the base. 0, 1, 2, 3, 4, 5, 6, 7. That makes you 7, 7. No, you're 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Unless this is considered 0. If this is 0, then it's 0, 1, 2, 3, 4, 5, 6. So that would make sense. 2 6's, and this would have to be 5. 0, 1, 2, 3, 4, 5. Okay, and this would be 5, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, 5. Okay, that's the system, which means these all have x0 and y0, 1, 2. That's what I needed. So cost launchers equals an array of, and yeah, we're not doing rows and columns anymore, so let's do x and y's. x0, y0. What did I put for the previous? Oh, I put the character in there to figure out the segment. I guess in this case the segment is in A, then B, and then C. There we go. I have to put them all in the same array and not make 3 arrays. Let's get those. Okay, now I have all my launchers. What we basically need to do is iterate through time, and for each iteration of time, try and hit it with all 3 launchers, right? That's what I want. I'm thinking, is the math the same? No, it's not. Because part of this in this event loop is I'll need to, well, effectively an event loop. As time moves on, I'll be moving the meteors and I'll be moving projectiles. So the way I currently do it is I just calculate where you would hit time agnostic. But now that time is a thing, I think I need to, like a game loop, simulate everything's movement 1 by 1. So let's just say, what are these? These are meteors, right? Meteors, yes. So it's an array of meteors, which is our targets. So I'll take that back. Excuse me. Right, so I think we're just going to keep running until we knock them all out of the sky. Excuse me again. Sorry, take a break there. And, not fully morning yet. So while there are meteors, I guess we want costs. What are these we're shooting? I'm shooting something. Cannonballs. Projectiles it is. We have none, but as we launch them, we'll need to make them follow the same logic as everything else. So let's see. Move projectiles. Move meteors. And then what do we want to do next? We want to check if there are. And then what? Sort by those with least. What are we calculating again? These power scores? Ranking values. Add a new projectiles. Now this is gonna be the fun part. How do I know when I'm firing new projectiles not to like shoot one with a power of 5 kabillion or something? That's gonna be fun. Trying to think. I mean, looking at the visualizations, try and help with that. Yeah, I don't see a good way to calculate this. Interesting. Because the power. Think. Maybe there is some way to determine. Right, because look at C here. If C is targeting a power of 1, 2, 3, 4, 5, then shooting at 5 wouldn't be what it would want. You'd want to shoot. Hold on. 5, 4, 3, 2. So that's just half. Maybe that's my ceiling for power. Just whatever the greatest one is, half. Let's try that. Cost max power equals meteors. Map m dot x dot x. We'll just math max this. But this is not the maximum power, that's the highest meteor. X does exist on a... Oh, sorry. Okay. I'm transforming that. There you go, you're not an array of tuples no more. Nice. Now I said it was going to be half. My odds, it won't be on an even number, so I'll have to floor it, and I'll seal it to be safe. Divide by 2. There we go. So that's how we spawn new projectiles. Trying to think if there's anything left I need to make sure. No, I think that's it. Okay, so moving my projectiles. Kind of weird because I haven't fired any. So the firing does need to happen after, or else we'll fire and then move them. But so looking at a trajectory. trajectory, how would I? Yeah, so I start off of like, I'm going, and then I'm going only, and then I'm going back down. Basically, there are 3 stages to a projectile's life cycle, and I can just put that as stage, and then based on which stage determines how it's moving. Got it. I will switch stages when it reaches a calculated position. That's kind of not simulating, that's cheating, it's knowing where you want to be. When I run out of velocity, because basically it's how much more can you go up, how much more can you go right. So if I represent this as velocity, it'd be +1 +1. And then you'd run out, and then it'd be just horizontal velocity. And once you're out of all velocity, you go down. Okay, so the x velocity in this case is 6. The y velocity is 3. And as you consume them up, you stop adding them to the default velocity, which is +1 -1. So my y velocity is actually 12 to offset the normal down. I guess x velocity is always 1. Well, it's not 12, because that'd be doubling the length. It's 6, and then it's 3. So it's not really velocity, it's offset. Y offset. There we go. Y offsets. 1, 2, 3, 4, 5, 6. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3. So it's power divided by 3. That's not always going to be 3. I'm shooting for power of 3. So if it was 2, it'd be 1, 2, 3, 4, 5, 6, 7, 8. Okay, I think I've fiddled with that more long enough. So for const launcher of launchers, I need to add I'm trying to think. This is for every time segment. And let's just generate a projectiles push, not oosh, push. X, launcher X, Y, launcher Y. And this is the thing I was trying to figure out. Let's just put power, and it's going to be another for loop over here. P equals 0, P less than or equal to max power, P plus. There we go. Power is power. Let's fix that. Loving it. And then you gotta know who originally launched you, so that's segment. Launcher segment. Okay. I think that's good. We'll use the power to determine what you are, so we'll just call you remaining power is power, and you know what, let's just make it really easy for myself. So I can just do some simple checking when I go to move them, which is what I'm doing right now. Projectile. So if projectile ups, then projectile y plus dot y, projectile x plus the number of ups you have left goes down. Other kind of down. There we go. Now, else if projectile right exact same scenario, but I don't increase my y, it just sits there. And finally, when you are out of either, you're going down. Throw me in there. Negative, negative, which all of these just have x increasing, so we're just going to move you out of the loop, or out of the conditional logic. And we want to be able to get rid of them once they hit the ground, or, well, if they hit a meteor, I'm going to do that down there. So we can do that, if you hit the ground early. How do we want to do that? Let's use a filter. We'll turn this into a let. Could do some for and some splicing, but we ain't being too efficient around these parts. Equals projectiles filter projectile dot y not equal 0. Basically, you haven't hit the floor. I think that's what we want. Yeah, if you haven't hit the floor, you're good. Yep, that's what I want. It gets rid of all the ones that crash. Now the moving of meteors. I think this is simple. It's just x -1, y -1. Feels like that's what it should be. Yeah, I think that's it for cos meteor OR of meteors. Meteor, do I have my numbers? I do. Y negative meteor dot x negative. Okay, so we have that. And now we kind of want to see all the projectiles that are at this position, and then for all those projectiles, which one is the best? So I guess I'm doing this both in here. That's fine. I'll do them separate, to be honest. These comments somewhat useful. All meteors at my position, basically. That's going to be a lot of iterations, because I'm doing that for every meteor. And I'm doing kind of a static calculation for all the other ones. This is what I really need. I need a map of the projectile positions. Do that calculation once, and then for each meteor, be like, hey, is anyone here? Let's do that. And we'll have this move projectiles. Yep, up here. What do we want to call this? For collision logic later. There we go. For projectiles. Whoops. You have a position. Projectile positions. We want to say where I am, which I can't. I was thinking of doing the cool math trick since we have two values. Let's just do the bad way. Key equals. I'm just gonna say x plus bar plus y. Woo, not provide a worker state. So the key, well, come on. Key, come on. Key equals, I'm just gonna add you to the array of people that are at this position. So it's the previous array. Nope, not arguments. Or an empty array, spread, and then a whole new projectile. Projectiles by positions. There we go, and then the meteor will generate a key. And we'll see cos colliding for gliding projectiles, which is projectiles by position. This key, it may be empty though. So if no gliding projectiles, then you keep flying, little meteor. You're gonna do great. Otherwise, we're gonna mark you as a collision and generate the cool number. Which one do I choose for the cool number? The ranking score. So I need to generate the ranking scores from this. Is that all I need? Okay, so I guess I gotta go through all colliding projectiles and add, hey, here's your ranking score. Colliding projectiles map. Let's figure out what I'm supposed to return for this. I want the entire original projectile, because for stuff. And I've done this calculation before, so let's figure this out. Segment plus 1 times power. Yoink. Love it. And then I want to sort these, not solve the quest. A dot ranking score. There's B dot ranking score. Do I want the lowest or the highest? The lowest. Okay. Cost best equals projectiles ranking score a 0. Once I have the best, I guess I'll need to take that. What do I do with that projectile? I gotta eliminate it, right? Well, there could be a universe in which there is. Well, I guess that projectile won't. It could hit other stuff. Is that allowed? Because previously, if the 1 and 2, once you hit something, your projectile dies. Let's worry about that later. I need to do something with this best. I'm looking for total, so I'll just add it to total. There we go. We have our total. Yeah, we don't need to do the math anymore. We're just returning these. Right, yeah, we hit it. Now we actually need to get rid of this meteor. We're iterating through it forward, so we could do a thing where we say, hey, you've hit a thing. Yeah, let's say meteor ranking score equals. Yeah, let's just keep it simple. Hit by, and then it is hit by the best, and then we do another filter up here. So we drop the cost, go to let. There we go. And then instead of projectiles, it is meteors. Not meteors. Meteors. Meteor, and then you don't have a best. Yep, you have not been hit yet. Not a record number, dang it. That's not even a record because that one's optional. I'll try to get too fancy. There we go, that's what I'm looking for. I didn't even put it on it. Meteor.best equals best, which don't even need the variable no more, just put it here. And yeah, best is not a good name, but that's okay. Sort collisions, I kind of just did that right there. Fire new projectiles, I'm doing that there. Okay, I know this isn't going to work first try, but let us begin our iterations. So, I'm so confident, put a breakpoint in here before we even do nothing. Let's do this. So we have our meteors, we have our launchers, the maximum power, which I say is 5, which, where is this? 0, 1, 2, 3, 4, 5. And that makes sense, because the time it takes me to get up there. Sure, I believe it. Okay, and then we have all our projectiles. I'm going to walk through them. I don't have any projectiles yet. We'll shoot them in the future. So yeah, we have nothing there. Our meteors move. So you're at 6-5. Oh, I can't see you because you're outlined. Then you're at 5-4. So 6-5 is here. 5-4. Yep, okay, they seem to be moving along just well. There are no collisions, unfortunately. And then I'm going to fire from every power, from every launcher at this position. So honestly, I think this is going to work fine. Let's... Oh, my scroll wheel decided to die on me. Let's get back up to the top. Onto our next iteration of moving our projectile. So... This is a power of 0. We should not be considering a power of 0. We are wasting our time. But we had a lot of projectiles in here, right? We have 18. Boy, that's going to get really... I mean, it is a consistent addition, so it's linear, even though it's by max power, which we have thousands in our thing here. Well, in our real one we do. So that could be trimmed a bit. All these low power ones don't serve a use. Yeah. Okay, let's just go through it. I don't think anyone hits with a power of 0. But we have other powers in here, so let's go to the next projectile. Oh, what did I do? Oh, all the breakpoints are gone. Yeah, let's just... What's gonna happen? I'll restart it. Yeah, it's gone. Okay, so it never actually terminated. Interesting. Which means there were never any collisions. I mean, let's run it once more. Yeah, it never hits anything. Yeah, that one down. Come here. Now, if I'm shooting all the possible projectiles at all the possible times, which is what this while about here is iterating, starting at 1, save myself some love. So my projectile movement could be wrong, or my collision could be wrong. So I just need to look at what projectiles I have left, I guess. Well, projectiles by position, really. That'll tell me the most. Yeah, so let's jump back in there. Because the one I'm looking for is C with a power of 1. So at time 0, it's C with a power of 1. But I'm not going to see that collision until time 3. So I need to get to the third time, which don't exactly have tracking, but it's iterations through the loop. So this is time 0, time 1, time 2, time 3. Right, and I have a lot of projectiles. Let me just see by position. That's what I care about. But I have no place to put my breakpoints. Okay, yeah, so I have a lot of them. Some of them gotta be a collision. That's what I'm thinking. And if there aren't, then we failed. Okay, we did. We finally collided. Colliding projectiles. Yeah. 2, 1. So X, 0, 1, 2, Y, 1. 0, 1, 2, y, 1. So it's right here. Okay, so we're hitting at this one instead of this one. Interesting. That's fine. I just want to make sure the meteor goes away. It's not the right one, unfortunately, but meteor go away. So we have... Okay, I get it. Mini collisions. Meteor go away. Meteors 3. Meteors 1. Okay, so you do hit it. You do collide. Okay, so I just need to put a little termination condition of, hey, if you hit the zeros, we goofed. So if meteor x equals 0 or meteor y less than or equal to 0, new missed meteor. Yeah, we just missed a meteor. We don't have the information. So that'll at least stop the infinite loops going, because they'll eventually crash in our face. Not the greatest, though. So we're shooting a lot. We're colliding with the later one that I wanted to see. So let's change from meteor's length to let time equal 0. Meteors dot length time plus plus. It's going to serve absolutely zero functional use, but allow me to see what termination is going on. Do I need to actually trace these positions? Because I'm feeling like I need to for visualization purposes. Do I have the information to trace these? So I'm shooting a lot of projectiles. I mean, I know that's not going to scale. Is there a way better to just not fire off as many? I'm trying to think. When I fire them off, doesn't matter. It only matters because it determines where they're going to be. If I fast forward their positions when I fire them off, that'll be less iterations. Still giving me the same amount of... Oh. No? Yes. Okay, I think that's just a different way that I stumbled into. Instead of going through all possible powers, we just add all possible powers based on the time we've spent so far. So at 0, we add all the zeros, and at 1, we add where all the 1s would be at this point, and 2, where all the 2s would be at this point. So this is actually more efficient because you only add as many powers as you need until you eliminate all the meteors. I like this. We're gonna do this. I don't even think it needs a max power because it's just until we hit. So it's time based. So it's x plus time, not that time. Yeah, we do start at 0, so this is good. Hey, remember when I said we weren't going to use this variable? Yeah, it turns out I was a liar. I need to generate power. Is that not just time? I don't like starting at 0. That's useless, so it's time plus 1. Which means all of these are time plus 1. Sure, just plus power. Yeah, so I modified my X, modified my Y to basically fast forward to the position of if I were to have fired you now, gave you the power, which is better. I don't know, let's see what happens. Now that we have that infinite loop catcher, nothing can go bad. Tragically bad, that is. Okay, now I guess I just need to look at these projectiles. I believe So now I have to see, do I actually have enough information to visualize them? Well, I don't have them typed, so that makes it hard. X, Y, ups, rights, power, segment. So I don't really have that information. I can add a history. I'm just going to add a history, and when I'm doing it for real, I'll turn this off. Which is, I guess, what? A launcher. I guess it's initial X, initial Y before I move it. But I also want where I want it to be. There we go. There we go. Now we have a history, and now when projectiles be a moving, they're going to be like, hey, let's add front or end, beginning or end of this. So I've added it effectively at the beginning. If I push it at the beginning here, it'll be double. So I want to push where I've ended up, so my current position. My current position ain't all that useful, so I'm just going to add... Yeah, I did all that extraction for nothing. So you're going to add it up in the beginning here for where I'm leaving. So projectile history dot push, not that many parentheses, x projectile x, y projectile y. And now at any point I can just be like, hey, visualize projectile and do the whole world printing kind of thing. Or visualize the world, I guess. Yeah. Okay, so we have these. We have the ones that haven't crashed, the positions. And then we have our meteors. So what information do I need to validate my assumptions? Do I know which meteor isn't being hit? I need to keep its original X. X, Y. There we go. Or detected. There we go. X, Y, which, yes, TypeScript loves this. At least there's a better logging I can do down here. Instead of being like, hey, meteor missed. It's like, which meteor? Meteor detected. This one. So without even running anything else or visualizing, I'll know which one's not being hit. 10-5. The one way here. No visualization for when you actually get hit, fella. That's okay. Okay, maybe let's break these up into smaller ones. Describe example test. What do we want to say? 6, 7. Whoa. I might find the wrong one. Put it back. Put it back where I found it. Which means I've been copying the wrong bits around. There we go. I'll put that back. Replace that with that. There we go. Drop this. So drop that. Drop that. There we go. Okay, test 6, 7. Let's get in there. Where's my test closing bits? They're right here. So let's get one for the entire. Not full. There we go. Still keep this one going, of course. I do have the expected numbers. I should put them in. Okay, that's individual ranking times. Total ranking. Here we go. 11. Okay. I'm surprised this isn't working without a trim. Weird. I'm gonna put a trim on there. Okay, so we have this. We have the full one. Yep, we have the full one. Let's do 6, 7, each individual. think they give another one there too. Both resulting in a ranking score of 6. I'll take it. And then great thing is I'll be able to debug each of these individually by looking on the insides. So 6, 7. Great. Who about 10, 5? Barely reachable. Yeah, you're the one I'm having trouble with. Makes sense, you're a fancy one. Only one way to destroy it. My ranking score of this shot is 3. Okay. And there's one more in here. 6, 5. 6, 5. 2. The ranking score of this shot is 2, so we'll follow this one. So your thing is a 2. So this one's easy. You find both. You just pick one. You pick the lowest, and you shoot the latest. I saw another one, 5, 5. Let's bring him into the equation. What's your ranking score? A 2. Sure thing. Okay, let's see if we have some happening. Nope. Let's hit all the example. Boy, none of them love me. I love that. Okay. 6, 7 is supposed to be the easy one because there's only one thing to hit. Let's go through it, I guess. Should have breakpoints up there. Alright, so you have new meteors, new collisions, all that fun stuff. So let's look at what we ended up with. My meteor moved to 5, 6. And I haven't fired a single thing yet. Interesting. Am I just off by 1? That's what this feels like. I don't have any good breakpoints. Hope I have the beginning at the top here. Let's go for that. So let's see what projectiles I made up. Oh, I guess we're not going to break up there. Cool. Meteor dot detected. Oh, that's when you detected them, yeah. So they say for 6, 7. Where'd 6, 7 go? B with a power of 3 or C with a power of 2. Altitude 4. 1, 2, 3. I don't. I guess it's at time 4. That's where they're saying. So time needs to be 4 before I make a thing. Sure. What's my time now? 2. Oh, which means I did just hit him. That's great. Okay, I'm doing an extra launch of projectiles. That's fine. So what was our total? What did we add our number? We added 0. Hey. Okay, so we did succeed. We hit you, buddy. Maybe my calculation is off? Okay, so I really need to stop scrolling down there. That is tiring enough. Looking at 6, 7, yep. Okay, yeah, skip that. We don't care about it no more. Yeah, well, you got hit, sucker. So, yeah, projectiles with ranking scores with a 3 or a 4. Okay, alright, 6, 7. From segment B with 3 or C with 2. Okay, so C with a power of 1. B with a power of 2. So my power is off by 1. Because the whole plus 1ing stuff. In which case I'm fine. I can fix my math. My power is off, and I think my power is off. Oh yeah, the number of my fast forwarding trick that hurt. Power. Because I fast forwarded it. I see what I did. I did the bad thing.
Um. Okay, let me think. Hmm. Can they both be consolidated into one? No, there's two scenarios. One where I'm not being decremented by y. Yeah, the three scenarios. I'm adding to my y, I'm just going, and then I'm decrementing. So yeah, my velocity, I goofed it. With this right here, if I just report my power higher, I think that'll be fine. Because these are already messed up in a way. So let's see if that likes it. No. Okay, let's get back in there. They shouldn't be zero. That's a problem also. So let's figure out why the heck there's zeros. Oh, I'm putting a whole projectile in there. Well, that would do it. I'm also not adding it to total no more. Where'd that line go? A whole bunch of half code just got lost here. Okay, so this is gonna do better. It's actually gonna be a number in there. Okay, good. Okay, good. Okay, okay. This is the one that they were complaining about. Like, oh, you're special. 5-5's also special. So let me. Yeah, 10-5. Why is it special? Barely reachable just above ground from segment C at a shooting power of 1. Did I do the thing where I was like, I'll never need to shoot at 0, and I accidentally never shoot it at 1? No, I have a projectile with a power of 1 here, which I immediately upgrade to a power of 2. Yeah, this is where visualizing the trace of that would help a lot. Interesting. Very interesting. Yeah, I think I goofed this up a bit too much here. Okay, let me go back to the movement code. So I've done 2 additions here. It needs to go up and it needs to go right. As it goes up, you get rid of your upward power and you go up. As you go right, you just get less rights. Which is a weird way of basically just doing this until that many times. So this can be double, but only half of these you would be going vertically higher. I think I need to visualize a history. It needs to be where the projectile is. So I guess it's down here. What do I want to call this? Visualize projectile. We need all of the things in our little world. We need the launchers. We need the projectile. We need the meteors. Nope, not whatever that is. Meteors. There we go. So let's bring that function to life. Function visualize projectile. Projectile and meteors. So cost. And yeah, we'll just times 2 it for every direction. Cost C equals meteors dot filter and dot. Then we do want the projectile. Highest projectiles band, furthest to right projectiles band. Cost max X projectile. That's how you spell the word projectile.
projectile dot history dot map h dot x. Then we'll max it. Boop, and then min. Well, max y, that is what we care about. And then we'll make those cost max x equals max x projectile times 2. Same for the y. Okay, and that will be the world we will draw. Excuse me. Then I think we just literally draw everything. So cost world. Well, we don't need a world. We can just draw the lines. So for, well, we do need a world because when I do this in debug, it never shows up well. World equals this for let x equals, well, it's y equals max y negative, well, y, and then y negative. So we can really just be like, hey, you're truthy. Well, we'll need, come on, there we go. If y, no, we'll just need the columns for let x equals 0, x less than equal to max x, x go up. Then we just get things at these positions. It's kind of almost expensive thing. Chords for const. It's honestly not that expensive. It's for visualizing too. Const watchers dot find l dot x equals x and l dot y equals y. If watcher, then let line equals an array, line dot push watcher segment, and then ampersands. Let's just do this. If y equals 0, line dot push the equal sign, and y'all done for. So yep, we found a launcher. We're gonna push you. Y'all are done for. And then what we're gonna do, find the projectile history. So path. And we already have that. It's just in the projectile. And we'll call this smoke, because that's what's behind a projectile usually. Projectile history, define h. Same logic, h x triple equals x and h dot y triple equals y. If smoke lines dot push, I can't find the right symbol to use for this. We'll just call it lowercase p, and then continue, and then if projectile x equals x and projectile y equals y. This is us. We found where you're currently at. The big P. We're just missing meteors now. Cost meteor find and that x. Same logic. Come on. Come on. Okay, we have all this going on. We want to do this. We want to take these lines, push them into our world. Switch that into that. Not on that. str equals world dot join on the new lines. World stream. Okay, this should be enough to see something. Let's make sure this works normally, I guess. Oh, the rest of things should be dots, I forgot. Okay, let's see what we got here. We don't have all the launchers. That's unfortunate. Yeah, the A is just like, hey, there is no launcher here. Did I goof on its definition? Come on, where are you? A, B, C. Do we not start anything? Yeah, we're starting at the right thing. You know what? Hey, you know what? Y? No, Y is the good one. Let's start X at -1, right? Sure, let's go for that. Make the drawing a little bit more realistic. I see a lot of nice drawings. Where the heck did my A go? Watch your LX equals LX and LY equals LY. Do I never hit? Oh, Y0. I don't think they should be doing this necessarily all the time. Yeah. It's -1. I put my floor in the wrong place. There we go, CBA. Now we have it. Okay, so you're here. Projectiles being fired off. There are no meteors to look at, you dummy. Okay, dude, we want to look at all the meteors. We are looking at all the meteors. Actually, I guess I need that for the meteors too, for these visualizations. 3.map. Let's get all the Y's in here. There we go. Yep. My projectile has gone 1, so we're going to show a 1. It's very unuseful. Okay, here we go. So we're going. We fired from A. We're going across. Oh, we're seeing everyone. So history does get skipped a little bit, unfortunately. And I guess we stop visualizing when there is a collision, not all the collisions. Dang it. These projectiles don't have IDs. There's no way to visually distinguish them from the other. Let's look at 10.5. At least we'll get something out of this. Okay, we see a lot of attempts, right? And I'm seeing some good trails. So they say your last chance is as it's on the floor. And everyone's just going into the sky. One person. So we do have some that are going down. So yeah, it looks like a power of 1. Maybe a power of 2. Right, and it's 1 behind where it needs to be. Okay, yeah, here's the visualization for it. Up 1, right 1, down 2. Up 1. Both of these are on the same line. I do not have a visualization for both of them being on the same line. Yeah, so I'm not shooting a meteor with that proper thing. Right. Do I just be like, hey, like that? No, they don't like it. None of them like it. Okay, I need to figure this whole power thing off. I better go back to the fancy way. or this is the fancy way, but we're going back to the boring way. I'm just firing them off at all the powers. Let's bring max power back. No, I said bring it back, not get rid of it. And then don't do a +1 on that, because that's weird. Have all my braces? I don't think so. Yeah, we'll find out. I found out. Easy way to find out. Okay, let's see if that makes it. No. No, none of them like it. 5-5 likes it. Good for you. So we just missed it. We shot too early. So that's a off by 1 error if I've ever seen one. So if I just report the power as higher than it is, that has no impact on anything but our calculation. We're still not shooting the right ones though here. Let's do some things we don't care about. Segment C. If projectile segment not equals C, continue, or return rather. Okay, that'll help us a little bit. Okay, let's get toward the end here. Alright, because we're looking at every single one. Shooting power of 1 is what I claim to desire, so let's get that on the conditional 2 not equals C, and projectile power and not equal 1. There, now we're only looking at the ones that are relevant. We have all the starting ones, which aren't that useful. That's not a projectile power of 1. How the heck? This thing's clearing, right? Yeah, okay, it's clearing. That's projectile power 1 right there. Interesting. The heck are these? Why am I seeing them? Where did the visualizer go? It's not C. Or not 1. I think did I just invert my logging? Nope. Let's just do the whole thing. If projectile segment is C and projectile power equals 1, then congratulations, you can see it all. What? There are no C1s projectiles? Right, because I am doing this. Okay, let's put a projectile of 0 back in the equation. They really puffer out real quick. Yeah, projectile power of 1. I feel like those are also off. Those are off. No visualizations. Right, because I just got rid of that one. We'll keep juggling these numbers. Okay, we finally got a good visualization of it. Okay, this one should be hitting. Am I doing a thing where I'm getting rid of the projectiles too soon? Ah, there we go. Not equal, -1. Yeah, if they go through the ground, then you care. If they hit the ground, you keep looking. Oh. Is my ground collision too soon? If it's less than 0 or less than 0. Right, okay, that's a little better. Collision stuff. There you go. You're actually hitting the ground now. That's what I want. This is a collision. Right here. We're looking at a collision, folks. Why you know colliding. Okay, there's a collision at this position. So it's -1, 0, 1, 2, 3, 4, 5. X5, Y0. That's what I'm looking for. Excuse me. Sorry, wrong key. There we go. Nope, don't want to look at that. Yeah, I just want to get to the one I seen. There we go, X5, Y0. Oh, geez, they've been all in here this whole time. Jeez. From C with a power of 1. Yep, you're here, buddy. Where are my meteors? X10, Y5? Oh, that's original. Yeah, X and a Y. You just found one, buddy. Oh, are we off by 1? Okay, let me see if the rest of them are... Stop this. Like, everyone could be off by 1 right now. Okay, I think everyone is off by 1. Not in power. Hello. Might as well. I was just doing that anyway. But in collision, they're colliding off by 1. I move projectiles, I move meteors. They should be in the same place to collide. Which means one of them needs to move faster, one of them needs to move slower. This 10-5 is the easiest one for me to debug on this, so let's get back in there. Alright, we have our meteors, we have our stuff, projectiles by position, this is what we care about. 2, 3, 4, 5, 0. Yep, we have 5, 0. And at this point, the meteor is at 5, 0. So if we move the meteor movement to post this, which right here, that could be far off by 1. Wrong one. Okay. Hey, okay, let's go find these console logs. Get rid of them. You know, don't get rid of the console logs. Get rid of the whole freaking function. And let's watch it kill my computer. Woo! Because we are spending a lot of projectiles up. This might even be one where I drop it out into another file, just to let it run and eat my computer. Q.ts. Where's my part 3 function? Right here. I think memory is probably going to be the first thing I hit, because I'm building huge hash maps and huge arrays. All things that will rarely pan out. Yeah, let's get rid of that for now. Still running. Yeah, expected. I'm just need to console log the output of the notes, which is right here. Boop. Drop the 2B. Just go up in there, drop the expect. There we go. 2024, 2, npx, tsx, q.ts. Come on. And that will now run. unexpected thing but found thing. Oh, sure, buddy. Also, probably should. Yeah, I'm gonna reload the window before I do that. Kill Jess, and then let the terminal run off. You have fun now. So, I think this is where I do need to do that optimization with power that I was doing, that I was like, get rid of it because it's too confusing. But now that I fixed the off by 1 effectively, I can do the cool stuff, where instead of going from 1 to kabillion, I calculate power based off of time. I think time plus 1 is a great place to start. Gratefully, I got a bunch of little tests that'll tell me it was not a great place to start. So 6.5. Let's look at 6.5. Yeah, shooting power of 1 at time 0. Didn't need to look at downloads. So maybe I'm skipping one. Alright, there was a fast forward bit that I had in here. Might need to restore that. No, it hates that. Okay, let me just think through this. So, my power, I want this to be based on time. Right, so, hey, you done terminal yet? No, you're still going. Okay, you don't want memory. Because the idea is that I should be able to fast forward where I am. Right, so if we start for the first iteration, it is 0, so maybe it is just time. No. I haven't tried this iteration yet. Still going, huh, terminal? You keep trying. No, it loves to hate that. So I'm just doing too much. Reducing the projectiles, I think, is where I would find the best wins at. Because there's just too many of them. I'll remove that line for this. Nope, still going. The idea is that I should be able to, again, fast forward based on where I am. So if I'm already at like 5 segments in, then let's just imagine we fired something with a power of 5 at this point. I'm trying to think if this is... It could be an off by 1. So let's get this working. So it was working closely. I think this might be another off by 1. Maybe I need to launch them first. But before I move them. So I do this, and then I launch projectiles. As to what these powers should be, I still think there should be 1 plus. Same for my X and Y offset. And same for the power I put into the actual everything. So we do know they all should be the same. We figured that out. We learned our lesson there. No. Okay, that's happening. So that happens. We move our meteors. Well, no, that happens. We check our collisions. We collide our meteors. Then we move our meteors. I know this is what fixed the last one, but this really is the way I envisioned it working. And nope, don't like that. No. Alright, so let me look at this it starts at 0, right? Yeah, and we're saying we start with the power of 1, then we fire something up. Starting with the power of 0 would give us nothing. I am fast forwarding the x and the y. I believe that is the right move, because otherwise... I really likes that, though. 6, 5. 2, 3. 6, 5. If I'm returning a 3, that means someone else is shooting, not this one. So it is just this one. So maybe I target this one and try and fix it. I don't like it, but wait a minute. Yeah, I think the fast forwarding was actually a bad move, because I was saying you're fast forwarded, and then I wasn't unfast forwarding it here. So I think if I do want to fast forward it, I just have to subtract from ups and rights accordingly. Let's try that. Which would be minus minus. We'll basically turn these both into 0, which, not what I want. I'm close to terminal finish. Oh, it ate all my memory up. Hash map, right? Heap limit. Yeah. Couldn't put anything else in that big map. I could reduce that slightly by just putting the scores in here. I just think the great number of projectiles is the problem. If I invert it to be like, hey, here are all the meteor positions, and then only look at those, that will do better. You know what? Let's go for that. So we're branching at this point effectively. Let's control Z a bit, because I haven't actually made a successful iteration change here. Okay, let's go for... none of these successful in my book. So we'll just do projectile by position, and we'll do the meteors in here. Nope, come on. Nope, come on. Projectiles, key, equal empty array. It's like, hey, there's a parking lot here for you folks. So basically we're going to do an if conditional. If key in projectiles by position, then you don't need to do all this stuff. You can just say projectiles by position, key, dot push, projectile. Boom, we made that a lot easier. We know they're there. I'm colliding projectiles. Is that... might not be any in it. I can't fix that for you, buddy. Okay, yep, that's all still working. Gonna take this... and I'll go to the next level. Projectile ranking scores. Right? Is that what these are? Yeah. Collision ranking scores. Collision ranking scores. Don't push the projectile. Push the ranking score. That's all we really care about. And you calculate that with projectile dot two things. Okay, that's better, which means colliding projectile ranking scores, and then you don't need to do the map, you just need to do the sort, and then not even the A dot, just A and B, and not even the dot there. I like that. Should still work. does still work. Yeah, you know, let's hit it while we copy this over. Don't move total. The total's perfectly fine. Where am I going? There it is. Off quest 3. Wrong. There we go. I'm gonna trim some more stuff as I paste it. Boop, we've pasted it. Get rid of the function entirely. Function calls are not free. Get rid of the history. History calls are not free. Don't even have history. It's not free. It stopped. Exited unexpectedly. Oh, it didn't give me a result. Well, that means this thing's gonna run relatively speedily over here. Okay, anything better? The filter's expensive, I know. Get rid of that keyword. Okay, I don't see any other easy optimizations. Let's hit it. Oh, come on. Dang it. Okay, maybe... I mean, we're still creating a new one. We're dropping the old one. It's what we would do anyway. The splices will probably be more expensive than it's worth writing them. Okay. Interesting. Okay. This is gonna keep running. So I am building all the projectiles. I'm sending them all out. Maybe there's a different approach I should be taking, because I am simulating this like time by time, which I thought would be the efficient way, because once I hit something, I'd be over it. I should be logging how many projectiles are left, honestly. Or no, not that. Meteors and projectiles. So that in here, console log in and meteors. P projectiles length, because I'm just curious at this point. Oh yeah, then be a lot of projectiles. We're adding a oh boy. Yeah, and they're all simulating and emulating for no reason. So even my other approach of just adding them as needed, it's going to be a great reduction, but not an elimination. I think with that, I'm going to get rid of the log and just be like, hey, you're going to do a slow time. Maybe you'll work. I will take another break. I am back. Fresh eyes, fresh perspective, full stomach, and I am thinking about the problem. So, basically everything I said was right before. I believe I need to do all those things. Let's see where I left off. Right, I left off in a good state. Good on me for doing that. I need to eliminate this. This happening is our main problem with efficiency. So I eliminate this, everything else should work. Now, I was doing the fast forward, but one thing I was doing was, since I was increasing X and Y, I didn't need this ups anymore. So I think that's what I need to do. I was doing it, I wasn't doing it enough. So, once more time. Fast forward our projectile generation. Const power equals time plus 1. Time. And then our X and our Y. I'll put them back in there because they are what we want. And now we use, because we're fast forwarding it by this much, so by that much power, by that much power, but we don't do any like ups because adding to the X and the Y, it is that first diagonal of our change. So now these are showing. It is this first segment here. So I wouldn't make it go up anymore. That's what our problem is. At least that's what our first problem is. So if I get rid of that, yeah, we still go right. The number of power. Power is power. Yeah, now that we don't have it, we can just ditch it entirely. A little cleaner. Alright, so I think that's projectile movement. Let's find out. Everything's broken. So they're all being missed. Now I think because down here is a fast forwarding, I think our order is all ruined again. So if I do, because this is when I move projectiles, these are effectively, these are moved projectiles. So this belongs up here. I don't know, let's see if that works. I think I'll need to reorder my movements again. Because we moved it here because it worked, not because it's where I wanted it to be moved to. Then yeah, sure, I guess we'll keep this here to anti. Ooh, good, good, good. So now we're just missing the 5, 5. We're just missing the 5, 5. What was 5, 5? Here's the example. Shooting from 0, collision at non-discrete. So at 1 unit, 1 unit. Shoot from at 2 with a power of 2. Oh, at 1 with a power of 2. Okay. That should be fine, because I'm shooting at 0 with a power of 1, at 1 with a power of 2. Yeah, I do that. Okay. So now we're failing, because this is the only one that needs a delay. With a power. Delay means it will be in the past, which should still be on our map of, yeah, this should contain all of like places we could have hit with our power at any time. Oh, I'm doing it based on the meteor, so it's only looking at places the meteor currently is, not places the projectiles have been, which is the way it originally was. So I gotta flip this back. Okay, let's flip this back. Which means this becomes empty arrayable. I might as well shove this back into there. Projectile, projectile. Let's do the thing. If not, then it's an empty array. Oh, let me in. And then otherwise, well, the otherwise is guaranteed. You can drop that. Okay, that a little better. Dang it, oh, okay, at least it ended early. That's good. Still failure. I didn't break it, but I didn't succeed it. Where does they get hit? So from a power of 2, it's 1, 2, to bring 1, 2. Yeah, so it's supposed to be hitting 0, 2, 2. So it'll hit like 2, 2. That's apparently not happening though. Hey, let me see what my collisions are. Yeah, 1, 1, 1, 3, 1, 3. 2, 2. It's right there. So where are my meteors currently at? 4, 4. Okay, so yeah, you'll go down to 3, 3. Maybe I've off by 1 to this. Where'd it go? You're about to go to 2-2. Where'd my... Oh, it doesn't... It sees all the positions that projectiles are currently at, not have ever been and could be. Well, that's useless. I mean, it's useful for... You're going to collide it right now, but not for the delay bit, I guess. Okay, good. Yeah, let's remove... Well, actually, we don't want to move the projectile, because it could hit something that would be a better use case, maybe? Or maybe we will. I don't know. We don't need the visualization no more. I hope we don't need the visualization no more. Do we need max power? Could we optimize it a little bit more? Because we are reducing the number of projectiles. We're not... Like, I think we're still throwing a lot at it, unfortunately. We could try... It's gonna make sure this still works. Okay, so we'll turn that into our Q3, or our QTS, actually. Let's grab it. I removed the call to it, which is the important... What happened? Oh, it failed. Okay, why did it fail? Oh, that's a number. First number we've had for this thing. Woo! Finally. Nice. Okay, I definitely still feel like I brute forced the heck out of this. 10-second runtime. Yeah, I brute forced it. But we got it working. And let's drop QTS since we didn't actually need to go there. And this initial. Let's make sure I didn't break the rest of them before we do that. 10-second wait. I will be patient. Initial 12 solution. Oh, there's a print in here. Or not a print, a console log. Yeah, drawing hit. That's gonna be expensive, but it runs. Okay. Initial 12 solution. There it is. Phew. That took a toughie. Okay, now that we have that done, let's walk through the actual challenge. So, we're given a world with positioned 3 launchers that turns out are consistent, and some targets that we need to hit. And then depending on what we hit them with and what power we use, we generate a value for that shot, basically. The one rule here is that we hit them from top to bottom, so you can't hit something below when there's something above. And you're going for the least value, or maybe there isn't a least value, just the value. Second part is that there are these blocks that take 2 hits in order to destroy. That's about it. And then the third one, where everything gets flipped on its head. Same launcher, same logic. You are now giving moving targets meteorites, and you're given their coordinates instead of a world to parse. They are constantly moving to the bottom left, so this direction. And you are to destroy them as early as possible, but with the least amount of score. So in this one, there are 2 ways to hit this as early as possible. So both of them will destroy it at the C level. But if you use the A launcher, the generated score for that shot, which is a tiny little algorithm, is less. So you would use that one instead. Same here. Meet them when the velocities intersect.
Yeah, there's can't shoot something between the grid positions. That's illegal. And yeah, that's basically all three parts of the challenge. Easier said than done. Okay, so now the great refactoring. So I think I will. It's interesting because the part one and part two and then the part three are really somewhat different problems with a similar base. Because there's no time and there's no looping, it's just destroy as many possible sequentially in the part one and two. The three, there is the time and all that. So at the very minimum, I'm going to normalize the behaviors. It just doesn't mean I can trim up a lot of stuff. So let's just clean them up in isolation and then try to make them beautiful together. This is one of the ones where I do not think I'll be able to generate a single function that does all the things, but that's perfectly fine. They're different problems. They deserve different solutions. So let's start with I was about to start part three because I have a lot of memory of that. Yeah, it's not really the right order to do it in. Let's start with part one. Okay, so part one, get rid of that breakpoint. We parse the world. That's the first bit of the logic, and the next is just destroy all my targets. So that's until all my targets are destroyed. Try and calculate the thing to destroy my target. Which honestly, not really a big problem. I kind of already did refactor this for part one and two. So one's static and one's moving. I think that's the main thing. Rules remain the same. Destroy targets. Destroy targets, and the other one is destroy meteors. Yeah, I think that's perfectly fine. They don't have a lot of overlap, especially in my solution. Okay, so targets, launchers. So we'll bring that into a parse function. Parse. Are these called launchers? Like, what are they calling them over here? Parse targets. Targets and catapults. Well, each catapult is 3 segments. Segments is too generic. I'll call them launchers. There we go, and I want to do basically all of this. And then I want to return them both. Return. I don't want to do it in this order. I know the order doesn't matter, it's an object, but I do like that order. There we go, and let's not use single letters when we don't have to. And I didn't do it there. So I said health, durability. Durability. I like that one a bit better. Row column. If you're a character, then you're one of these 3. If you're not, then you're not a thing. Yeah, then we have sorting going on. Let's do that a little more inlined. And this one is great because you can return one or the other. I just did it explicitly because a time. And this or this. And we don't even need to OR the 0 because those will be zeros if the ORs fail. Nice. Now here I can use that cool function. So const, come on, equals parse targets and launchers.
pass the notes still. And 1 and 2 should still be functional. I need the world. So I guess it's just parse world at this point. And these are part of the world, so whoop-de-woo, even though the world's just the string matrix. Okay, part 1 and 2 should be perfectly happy. I broke it. How did I do that so quickly? I changed the sorting. That's what I did. Oh, I also changed it from durability from health to durability. Yeah. Oh, I got an old breakpoint there. Let's get rid of that. Boom. And part 2 was the one that failed because part 2 actually used the health / durability. Complete sense. Get rid of this breakpoint. Okay, so we have the destroy, or the parsing rather. So try to make this a little better. So for target and targets, I literally don't use the T. For launcher and launchers, I don't use the L. Once you hit it, we got a boolean and we got breaks, so we got a lot of grossness there. So let's for const target of targets. Targets. That'll also allow us to rename dest to target. I love it. Then we'll go through all our launchers for cost launchers, which will allow me to drop the origin for a launcher. Much more accurate. Still working. Yes. Okay, then we have some stuff here about hitting the target. Definitely going to go into a function. Target hit, calculate hit target, something like that. It's going to contain basically all of this. Now let's just start with the easy one. Attempt to hit. Attempt to hit. We have block, dest, block. I think it's basically this entire contents, the blue one. Without that, so for every power, so we do need the world, which I think that's what the world is. Okay, and I just renamed all of these to make them more generic. Origin, target. Yeah, target's actually, you know what, instead of origin, source. Instead of pushing this, we do some other stuff. Yeah, and then this is where we return const hit equals, I guess all I really need is the power and the number of times to hit. I'm trying to think if we could just do the power plus 2 or power times 2, but there's some math down here. Ooh, let's not get fancy, and then we'll try and get fancy. So let's just say hit equals power, return power times target ability, which makes me realize is in the segment 2. We'll figure that out later. If lock above target, basically we flew over, give up. So this isn't a location, this is a equals lock and their ability. So let's get that type properly used, which I already have it right here, I just haven't used it. Boom. Do I not know how to spell the word durability? Looks like the right spelling of durability to me. This is happy. Oh, target. It's a type of target. There we go. So when you attempt to hit, you're going to give me this thing. For launcher, const hit equals attempt to hit to the world, the launcher, and your target. And if hit, then hits dot push power times yeah, I'm always going to return something. There we go. Now I can just kind of do this in a functional manner. Hits dot push. It's not telling me the where. I have the launcher where, so I do have the where to get that segment. So this will be new, or which way I want to do this. Array times fill. Yeah, the fill's perfectly fine. Still want to do this. Power segment, which is where we launched ourselves from. I think that will be perfectly good. We need to track if we actually did make the hit, though. Basically, if the length changes, cost prev hits equals hits dot length. So if prev hits triple equals hits dot length means we didn't hit it. So we actually want the invert. That was a lot of changes. Yeah, of course that'd break. So this segment I decided to shove in there is not correcto. Bummer. Do I get a lot of not hits? No? Okay, it's just one. Probably both of them. Okay, I wonder what I'm looking at here. What did I shove into my array? A bunch of empties. Oh, yeah. That's it was supposed to be a spread. Oops. There we go. This is the functional way of adding times number of items, but I just added an array of times size, which is a bunch of empty arrays. And that works. I like it. This is a little janky, but I think this is pretty good. Okay. We'll drop the else. Well, the else is really just a throw new to hit target. And what target is that? That is the target called target. Boop. Drop that. Love it. Okay, it's getting a little better. We're doing hits and then we're reducing it. We don't need to do this. We can just... Well, we do need to keep track if we have hit, and we're using the length for that. We could do the calculation for this here. So let's say function calculate rune. No, not rune. Ranking value. And then what do we need? Power number. Segment string, and then it's this math right here. Return segment times power, drop the parentheses. We have this right here, which means we can move it higher up. Instead of filling this with a bunch of wacky, just fill this with a call to this, passing your power and your segment, which is right here. Which means that calculation only happens once, because fill is a cool thing. Like this gets called once and then duplicated times number of times into the array. Now this just sums them up, and it's not even called hits, I'd say. This is called ranking value hits. Ranking values, I guess. Fired ranking values. It's all the same. Okay, it's better. Don't know if I like this jankiness here. It would be another function to wrap it, basically, and be like, hey, did we or did we not hit? What is the thing? Once you hit, there's supposed to be a break here. Oh yeah, there's supposed to be a break here. If well, I mean, there what used to be a break here. I guess the way the problems are laid out, it's not necessary, but logically there needs to be this here. Which means there's for efficiency of calls. Let's go in there. Okay, I like this. Let's space that a bit. Get rid of it on the board. And then return it. I love it. Yeah, like I said, I don't think I'm going to optimize this main part too much. Well, part 1 and part 2, it does its job. This was a bit of a weird way of figuring out when I went too far power-wise, but this target pushing launchers or target. If TRH, and then that can be, like this can be squished into one line. It's fine as is. We can do outside of this range, flip this to continue, but it reads pretty well like this. World launchers, targets. Launchers, targets. I think this is all perfectly fine here. This, I'm really sad I had to do this manual on every iteration. So this is where I could optimize it to get quicker calculations of destinations. Calculate hit. Yeah. This calculates where it hits. So we have location, which I don't even give it a name. You're in the world with that much power, aiming at the target. Ooh, I could do some weird stuff and be like, assign some stuff to the target instead of having to return this lock above target. But that'd just be weird juggling of things, and this is fine. I do think these are relatively easily split out. Somewhat easy to follow. You can see the 1, 2, and the 3s. Okay, now the next one. The Meteor Destruction. So this got a bit TypeScripty here. Function parse. We can definitely do this one a little better. And then we can bring this one up to here to say, hey, look, you're returning an array of these. Type expected. Whoops, I got an as in there. It's a little better. This detected isn't useful for anything but logging. And this best, yeah, that's gonna get refactored. Let's figure that. Meteors equals parse meteors. So I did make it a const. Let's keep it a let because we've got all these ugly filters down here. We have our launchers, we have our meteors, collision ranking scores. This isn't. So yeah, these are ranking scores where collisions are possible. I don't like this name because what this really represents is every position that can be hit by a projectile and what the score is to hit that projectile. So, well, come on, F2. Hittable coordinates, I guess. Let's get that type going. Well, it's a string to a number. Oh, you know what? It's not. It's to an array, but it shouldn't be an array because I'm always just getting the best one out. So it should be setting it to the best possible, whatchamacallit, ranking value. So let's just make that better right now. So hittable chords key equals what it'll be, math dot min. Yeah, we're going from A to B, so that's ascending. We get the 0, so we want the least one. So it's this, or and then what is it? Number max safe. Going for the min. The value I'll provide will be calculate ranking value, which I'll give you my projectile power, my projectile segment, and I got like no types going on, so this is painful. So it's not ranking scores, it's just ranking score, and it might be number dot max safe integer. No, let's just let it be undefined. If I ain't got one, then I ain't got one. Otherwise, I got one. Right? Feels right. Luckily I got half a dozen examples that I'll say so too. So that's a great memory decrease. Still a lot of memory, but it's less now. Ooh, we're gonna turn these keys into math real soon. Yeah, let's go ahead and do it on the inside. Let's continue just for one. It looks weird. And yeah, this is best. We're renaming this. Collision ranking score. There we go. It's a little better. Yeah, we're gonna do bad stuff too. We're gonna do this, because you can do that. And no one's gonna stop me. Do I really need... So the only reason I assigned this is for me to do filter, so I'm gonna look into filtration later. You know, we have the mist there. Again, that's just safety checks. So yeah, our projectiles are all up here doing their thing. So I have it as time, and I just use it to turn it into power. Oh, it's tempting to rename that to power, but I'm going to stay with the derivative value because they do have different meanings. Right. I mean, rights does work. I do need the original power. Horizontals, I guess, is a little better. Oh, let's drop this history while we're here. Let's get some types on some of this stuff. X number, Y number, power number, and it's just be a thing of arrays, that's why it's angry, in segment number, or segment string rather. And yeah, you get no history. Boom. You're always moving, and then based on if you're going horizontal, this can be one-lined. Let's make sure this still works before I get fancy. I love it. So I need something and then value. So if decrement not actually, we don't want to do that always, because that would be a waste of time. I was trying to do like inline conditional, the change and the check, but then that'll put me below 0, and it's like, okay, we don't need to be doing that. Okay, I like this. So get that 10 seconds done. I made a lot of changes without checking on 3. Might be regretting this now though. I haven't had a situation in which, ooh, cut by half. B-E-A, beautiful. Okay, I'm liking it, I'm liking it, I'm liking it. This still happens. So we have key optimization. We have removal optimization. Okay, yeah, so max X, max Y. I believe that's based on the meteors. So meteors,
max x, max y. Let max x equals number, min. Let max y equals number, min. And y'all will do your job. Max x equals math dot max x, well, itself. Very easy. Advanced code never yet seen before. Okay, now we have all these. We're returning meteors. Now we return all three. No, what the heck that was? I've done something wrong. I mean, aside from the typo, I've done something wrong. Oh, my type is inaccurate. Can we just do implicit stuff? Yeah, we'll just run off the implicits. That's good. Okay, and now we can convert to a thing. Collision ranking score. Well, you're right. It don't exist. Now it does. There we go. Okay, so I want to do this trick. I've already done it before. Don't know where, though. Populations of 12 days. I need a world. That's where I use keys. Sample key. Here we go. Row times column count times column. That's what I need. Okay, so I just need to do it in both places. Function key x number y number max x number max y number. Again, a lot of parameters. It helps. So return SR, which is the row, which doesn't really matter which as long as I keep them consistent. One of them being large and the other will be a problem, I think. Okay, we'll figure this out. We'll just do it one way, and then if it's a problem, we'll conditionally do it the correct way. So x times max y plus y. Let's see if that works. Key. Whoa, where'd my characters go? Equals meteor x, meteor y, max x, max y. I need some commas. Drop that. We'll do the same thing for our projectile. And then we'll see this go terribly wrong. Yep, this is where I expected some terribleness. I was running on the wrong parts. Jeez. So yeah, it could be because they're the other way around. So whichever is bigger is the one we need to do the multiplication by, I think. If it's wrong, I'll just flip it the other way. So I'm pretty sure I have the insides correct here. I think this one goes down here. So y times max x plus x. There we go. I'm feeling a bit more confident here. Not that confident. So either they're backwards or I'm doing this completely wrong. We'll find out. I've goofed it. And this is the only change I've made. So if I go down and put the comments back, it'll start working again. Whoop. What? What did I do? I did an undefined. Triple equals 0. Okay, I think I goofed on that. There we go. So it's working now, and these keys could be right. I'll put them back. So both iterations of my attempt. One of them's valid. Okay, let's see if I got this one. Okay. Now, did I just get lucky, or does it not actually matter?
You took 1 second last time. Okay. What is my max X and max Y? Because I'd be curious to see that. They do vary, alright? Then in the real one, what do we got? What do we got? They're different. Okay, so if I were to do a 10,000 by 10,000 or something by something, I believe this is the right way I have it. If I wanted to, I could try a test for this to make sure this is going correctly, but it's working, so we good. Which means our key production is a little less laborious. Technically, that's a comparison that needs to be done once, so let's do that in here. And you know what? Parse meteors, you're gonna return the function. Do-do-do, do-do-do. And this is going to take X number, Y number. Well, the value is going to be the variant of this way. That's this way. And then we do this. Otherwise, you return a function that does the other thing. And we're doing it this way, so it's a, not compile time, but basically it's a one-time operation of figuring out which math to use. Then every time you call it, you just use the right math. Which means I don't even know if we need them to be surfaced from here. Do we use them anywhere? Okay, we use them down here, but these were where we used them. I don't think we need these maxes. We don't. Boom. Which means they're just here to generate the function. Love it. It's a little janky here, but it's alright. Got a little character in it. Still works like a charm. Boom. Okay, I believe the last thing is my splicing or removing of projectiles and meteors. Now, this works perfectly fine, honestly. I was thinking as an optimization, like if we needed it and if it was a problem, what it would be was effectively not even going full linked list, though that would probably be the super optimization. Just noting the indexes that are slated for removal. And then, if there are 3 being removed in a row, splice a single operation. But I think this is honestly fine. Because if I did generate those indexes, then I need to consolidate, generate ranges from indexes for overlapping and all that stuff. I think this is fine. What we can do is, and we'll just do it for which one of these? We'll do it for this one. For P projectile of projectiles dot entries. Here's the thing, I need to go through it backwards from last to first for splice to work properly here. So I need reverse dot entries. Put it back for let P equals projectiles dot length -1 P minus, and then we have cost projectile equals projectiles P. So that part shouldn't have broken anything. We broke something. Oh, do I need to do? Whoops! I'm not gotta include your zeros. Okay, there we go. So we do that, and then we say, hey, if projectile dot y less than or equal. Well, there's only one way. If you're a -1, then we gotta say goodbye to you. Splice P1, and you're gone. .8, 5.3. Again, we're not gonna really see a great deal of increase here. Yeah, but it includes the removal in the thing itself, which, I don't know. We get our projectile, we increment it. We only need to do this check in here, so let's save ourselves a life. And you know what? That -1, I don't know if we need it that way. Less than or equals 0. Can we just say that? Or throw somewhere we need it at 0. Because 0 is technically the coordinate right above the ground. So we did need it there. So it's less than 0. So basically means you are in the ground. Yeah, it's going to work. Works beautifully. Let's do the same thing for meteors for consistency. For let m equals meteors dot length -1, m greater than or equals 0, m minus. We did that. Cost meteor equals meteors m. We did that. If you are not undefined, then congratulations, we got you. And we're going to splice you away. Meteors splice m1 means we don't need the filter and we don't need the collision ranking score. Yeah. Simplify our data structures. We're really, we have detected. We could rederive this from something else, honestly. We could just go back up that many times. Well, x equals x plus time. Cost of y equals y plus time. There we go. Yeah, well, it's meteor x and meteor y, but missing x. Whoa, x, y, a y. Yeah, I like that a lot better. We don't need to keep this detected around. I think those are right. Yeah, subtract on both means we add them back on this side. Good. I realize it's just error reporting, which very little to no impact. If ranking score not equal undefined, we do the thing. We need the key elsewhere. Nope, we just need the key once. We need the key elsewhere. Yep, we need it twice. We have the meteor, we move the meteor, we see if the meteor is hittable. If ranking score, this is fine. It's a little not readable, but it's good here. Now here's the cool thing we can do. We can say if the current y, so it's give me, then increment, we'll say decrement, then give me. Hey, again, real fancy now. And then this can be an else if. Drop some curlies, drop some curlies. I just destroyed the readability because I put some magic in a conditional, but nobody's going to stop me. XY horizontal power segment. We need the segment for math later. Do we need the segment for math later? Yeah, we need it for later. We need the power for the same math later. Can we just store the ranking value in the projectile? Yes, we can. Let's just do that. Value. It's a ranking value, which is your power and your segment. There we go. Let's get types up on this. Drop the power, drop the segment. We have a ranking value right there. Yeah, you don't need to worry about it. Just get the projectile ranking value. This does mean we are possibly unnecessarily calculating a ranking value for things that may never hit anything. I'd say that. But then we're looking at every position we are calculating. So actually we are reducing it. So this is a good. Let's see how great it is right now. Very great. We need horizontals for how many horizontally we move. Yeah, we can't get around that. We need the X, we need the Y. Feeling pretty good about this. Let's separate this out a little bit. Move projectiles. Do projectiles. Track. Hit a little coordinates. Meteors and detect collisions. And this will be detect mist meteors. I like it. I'm pretty happy with it. Not happiest about this calculate hit, but I'm pretty happy with it in total. Let's make sure it all works. And yeah, we did cut our runtime in literally half, so that's a nice. Let's do optimize 12 solution. Yeah, so now that I've written it, I've already walked through the challenge. Let's walk through my solution. So we'll start with part 1, which part 1 and part 2 both call destroy targets. Takes in our raw notes, parses the world, which just turns the world into a matrix of strings. Then we keep track of launchers and targets. So for every row and column, we look at the character. If it's alphanumeric, then it has to be a launcher or a target. If it is of these two kind of targets, then we push it to targets with a varied durability. We're gonna do it. There we go. If it's one of these, then plus durability is 1 plus whether this is truthy or not. Gets a little bit of Boolean magic. The old unary operator. Don't worry about it. This is also a part 2 thing I changed. Is it running that fast? Okay, yeah, it's working. That's all that matters. If it's a target, then we'll push it in a target, row, column, and durability. Otherwise, it's the launcher. We then sort our launchers from top to bottom to ascending. And our rows are top to bottom, so we sort them top to bottom, the highest to the lowest, so it's CBA. Our targets, we sort them from also highest to lowest and then left to right. I lied. We sort them. Yeah, because I use rows and columns in this one, so that's why the math's a little escaping me. I also killed Jess, so I'm going to reload this real quick. Or not. I just killed VS Code. RIP. Oop, and it's back. There we go. So let's look at it once more. Our rows are every row, our columns every column. So we are sorting this from a left. This literally does nothing. What the heck? Well, I'm glad these inputs are so friendly. I think the way I wanted to do this was the opposite way. I'm going to try it. So this sorts from the highest in the world to the lowest in the world. And then this sorts from the leftmost to the rightmost, so the closest to the furthest. Yeah, that's what I wanted to do.
Apparently it doesn't matter too much, but it's the way I wanted to do it. The main thing is that you don't try and destroy things below first. So as long as this part is ascending, you're good. Because if you do this part descending, that means you're trying to destroy stuff on the bottom first, and that's not physically possible. Because we're using physics, not teleportation. So we have our world, we are our launchers and our targets. For each of our things, we're collecting the ranking value of the hit. We check against previous hits to see if we were able to hit this one. Just a little safety check. For every launcher and every target, we pair them together. So we go destroy targets one by one, trying with every potential launcher. We call attempt to hit here, which goes through all the possible powers, calculating where you would hit if you were to aim from here to here with this much power. If you hit your target, well, good job. You hit your target and you're supposed to hit them however durable they are. There's also a bit of magic coming from this function that returns if we ever fly above our target. If so, then that's what determines we've tried enough powers. If you fail, then you hit it 0 times the power of 0. This is the oldest bit here, where we kind of manually emulate all 3 parts of the trajectory. We emulate where we start, and then going up and right. So the upright trajectory, which is right here, the up and the right. For each one, unfortunately, we are checking that if we are above the target, which is this means we're on the exact same column and our row is less than their row. We're above them, congratulations. We can also do an early check here, if not, and this just makes it a little easier for it to quickly short circuit and be like, oh hey, it's not, no, stop trying to check it, you've already found them above the target. But getting back to it, then we have a horizontal move, which is just the left to right, so only our column is incremented. And then we have our 45 downward angle until you crash, which isn't based on power, it's based on until you crash. So until you hit the target, or hit a different target, or go below the world, which is basically hitting that equal sign. You're just going to keep going down and going to the right. Finally, we return wherever you hit, that may be, and your location above the target. Interestingly enough, this does mean that you can't, say there was a tower right here, like just in your horizontal path or in your vertical upright path, I wouldn't be able to detect that. I only begin the detection of, have I hit something when I'm beginning my downward trajectory. But it's not a problem. We do that attempt to hit. If we hit it at least once, which times will be truthy, we add that many times of our ranking value to this, which now that I'm looking, we don't need to. We can just sum them up. But we did it fancy to keep this single responsibility true. If you did hit it, stop looking. Do not try and hit the same target with multiple launchers. Assuming you hit it, clear the board, so that way things can be hit below it. If you didn't hit it, then we failed tragically. Tell the world. Finally, just sum up all the ranking values. That's part 1, and the bit of part 2 where there's durability, so sometimes you hit them twice. And then there's the part 3 solution. Starts by parsing the meteors. So we both parse the meteors themselves and the minimum and maximum x and y. We use this solely so we could generate a single numeric key for our coordinates. Just make it a little less effort later on. Doesn't need to be as we saw earlier. You can just concatenate them with a random character, but I like this. We'll do a little trick here where we define the function with a conditional. instead of having the conditional and the function body. So we check this once instead of every time it's called. Then we hard code our launcher positions because we're not really given anything. We're just given meteor positions. We keep track of every coordinate that has been hittable. Keep track of our projectiles, and finally our total, which is what we're looking to do. We iterate through one frame at a time, continuing to iterate until all our meteors are gone. And we move our projectiles, so they always go forward, and then if they're going horizontal, then they don't go down. Like, they still have that horizontal power. If otherwise they are not going horizontal, then we're decreasing their Y, so they're getting closer to the ground. If they get so close to the ground that they are under the ground or have hit the ground, we get rid of the projectiles. They are gone. We no longer care for them. So those are all the current projectiles. Then we spawn new ones using a little bit of trickery of like kind of fast forwarding. So that's based off of time. We calculate the power as like we're this far into the future. Thankfully, our X and Y can be directly additive because we always go up that many power for the top right diagonal. And then we just calculate the ranking value here in line because we don't need the derivative values anywhere else. Finally, for every projectile, we're like, hey, where have you been recently? You've been here? Well, I'll let the world know that if anyone else shows up here, you could have hit him. Finally, we move our meteors and we look at the meteor's current position and we say, hey, are you currently somewhere where a projectile has been in the past? If so, well, you're going to use that projectile and get hit by him. I do think there's a thing here to be said about projectiles or meteors behind meteors where projectiles could hit both, and it's like, well, which one did it? I think that's being fully handled here, but don't worry about it. We have some error checking to make sure we don't go infinite loop crazy. And yeah, I believe that's the last line of code. So that is the entirety of this solution. I know it's a bit of a longer one, but there's math involved. And I know for sure I did not use any optimal math here. Very simulation focused approach, but I hope it was a pleasure.